Alright, today in Pre-Calculus A, we're going to be talking about solving systems of equations with three variables. Okay, now you can use all the methods you want. Substitution, elimination. Those are probably going to be some of the last steps you're going to use. There's also one called reduced row echelon, and involves using the matrices form of it. It's called an augmented matrix for the actual thing. What I'm going to use is a method called solving by matrix. Okay, and I'm going to show you this one right here. And this one, I'm not going to go too much into reduced row echelon because it actually is a little bit more interesting than what I would like. Get rid of that. Okay, but reduced row echelon, let me shrink it down a little bit. Okay, pick any two pairs of equations in the system, then use addition and subtraction to eliminate the same variable for both pairs of equations. That leaves two equations with two variables, one equation for each pair. Solve this system using the addition and subtraction method, then plug in the solution back into one of the original three to solve for remaining variables. Alright, so it just works this way. You just kind of work with it and then you actually just plug it in. I mean, it's pretty simple. So like for example, solve the following system. Pick the two pairs. Alright, 4x minus 3y plus z equals negative 10 and 2x plus y plus 3z equals 0. Okay, and we are going to probably eliminate more than likely the 4's, the 4x and the 2x. So we multiply the bottom by negative 2. Okay, you add them together and now you have a system of two equations. Okay, a system of equations with two variables. Okay, so you know negative 5y minus 5z equals negative 10. Okay, and you also know 2x plus y plus 3z. Okay, and you eliminate the other two and you get another equation, then you solve that system. Okay, and thus z equals negative 2 and everything else becomes really easy. It's just a two-step type process. Okay, but solving by matrix. Okay, what I like to do is make a coefficient matrix and then I times that by my variable matrix equals the answer matrix. Okay, now the best way to get rid of this is do the inverse, find the inverse of the coefficient matrix and then times that by the coefficient matrix to get the identity matrix. And then I have to do the inverse matrix to the other side as well and times that. Okay, now these two are going to cancel out to be the identity matrix, which is just 1 in matrix terms. So variable matrix, or the value of the variables, is going to be the inverse of my coefficient matrix times my answer matrix. And when I do that, I should get a really close answer to what it actually is going to be. It's really kind of cool how it works. Okay, and I highly recommend, if you haven't already, I recommend metacalculator.com for their matrix calculator. We'll look at this more and more as we go, but you put your inverse in, you calculate it, you get the answer down here in the results, then you retype it in, and then you times it by the answer matrix over here. Okay, and if you've been in Algebra 2 last year, you'll remember this process. I've explained it before, so that should be really easy. It's totally up to you how you want to solve system of three equations. Okay, alright, thank you guys, have a great day.